In chapter 4, problem number 61, the problem says the motion of a ball being thrown up is in the table. So here is the time and then what the height of that ball would be. We want to use technology to create a scatter plot for the data. We're going to go ahead and use the TI-84 plus. And so we're going to go ahead and first hit the stat button, S-T-A-T, and you want to type this data in. So we're going to go into number 1, edit, number 1. And if there's any data already in there, you want to clear that data out. Go up onto L2, hit clear and hit enter. Go up onto L1, hit clear and hit enter. Now I need to type the data in. In this case, I have the times, that's my L1, that's my input, and my heights, that's my L2, that's my output. So in L1, I'm going to type in all my times, and in L2, I'm going to type in all my heights. I've actually already done that, so I'm just going to copy them into there. But you would need to type yours in. So here's my times. Those are all my times in there. And then here's all of my heights. Whoops, I have got the wrong one. So let's clear that out. Oh, I know what it was. Sorry. So you should be typing yours in and get all your values in there. All right, so there's all my heights and there's all my times. Make sure you have all of them in there. So make sure that you have the same number of heights as you have times, because you would hate to have, you can't plot it if you don't have them same values. Okay. Now what I'd like to do is just look to make sure there's nothing in my y equals. The top row is all the graphing. So I'm going to go into y equals. If there's anything there like there is in mine, I'm going to hit clear to get rid of it. Then I'm going to go into second y equals, which is the stat plot. Since I put these in the stat menu, I'm going to go in the stat plot to plot them. There's 3 different plots. Pick plot 1. You want to turn it on, so make sure on is dark. Hit enter if it's not. The type, you want the very first type. If it's not the one picked, hit enter to pick that one. And then your X list is where your input values are. They are in L1, and your Y list is L2. And then whatever mark you want to do, whatever color you want. Then I'm going to hit the zoom button because I want to have the calculator figure out what's the best window based on the data we put in. So I'm going to use zoom stat because I put the data in stat, and the zoom stat will pick the right window. So you can either arrow down to number 9 or just press the number 9, and it'll give you the data. So here's my graph. You can take a picture of this, put this in your homework, and you now have a nice picture graph of this. What I notice is that this looks like a U, an upside down U. I know this isn't going to repeat like the parabolic ones that kind of look like this might repeat again, but this one, the ball is going to go up and come back down and then hit the ground. It's not going to, for some reason, come back up again, unless it's a bouncing ball. But even that isn't going to repeat like this. So this is most likely a parabolic or a quadratic. So I'm going to go up and look at my different models. Again, go back up to the top, look at the different models that are in the start of the modeling section. And what I have once I get there is that I do happen to have a parabolic or quadratic. And it looks like y is equal to ax squared plus bx plus c. So that looks like the right equation for us that we want to use. And that looks like the values we want to go with. So we're going to go ahead on this value. We're going to go ahead and determine, we now have the scatter plot. Now let's go ahead and use technology to create an appropriate model for the data. So I think it's quadratic, so I'm going to hit the stat button. I'm going to move over to the word calc for calculate. There's a linear, L-I-N-R-E-G, that's linear regression, AX plus B. There's also QUADREG, that's a quadratic regression. Parabolic, quadratic, parabola, they're all meaning kind of the same thing. So we want to actually use the quadratic regression because we think it looks like a quadratic equation models it. So we're going to go to number 5. I'm going to hit enter. Your X list is where your inputs are. My inputs are on L1. My Y list is my outputs. My outputs are on L2. Don't worry about the frequency list. But I do want to store the regression equation because I want to be able to use it. So I want to tell the calculator where to put this regression equation. I want to put it in my Y equals so it can plot it on my graph. The way I do that is I hit the vars button for variables, move over to Y variables because I'm going to put in the Y equals, and I want a function. And there's a whole bunch of different ones you can pick. You doesn't matter which one. I might as well just pick the first one because that's where I am. When I hit calculate, it will then calculate that regression equation and put it into the Y1. So I hit enter on calculate, and there's my equation. Again, the equation is Y equals AX squared plus BX plus C. A, B, C being my parameters, it gives me the values for those parameters. So now I can go ahead and type in what is my equation. So my equation is Y is equal to A, which is negative 495.7, let's say, X squared. So again, the caret is the square. Plus my B is 234.4 times X. Plus my C, but my C is minus, so minus my 0.0363. So there is my model that models this data. I want to also determine the R squared value. The calculator gave me the R squared value. It's actually 0.99979. So we can round it off to 0.9998. I can't round it any better than that because it would round it up to 1, and we don't want to go to 1. This means that 99.98% of the variability in the height of the ball is explained by the model, which means that we're actually getting an idea about the fact that most of what's happening to this height is explained by how long it was in the air. I mean, there's a lot of physics behind why it happens that way, but that's what's going on. Now we'd like to use this model to estimate the height at 0.25 seconds. Well, I want to go ahead and look at, if you click on Y equals, there's the equation we just wrote down. It gives me that nice equation. It already puts everything in. It doesn't actually round anything off. If I hit graph, it will then take my data and superimpose the graph that we have. I can then calculate the height of this at a certain time at 0.25 seconds. I can do that by calculating. There's a calc menu in the graphing. So if I hit the second button and the trace button, I get the calc menu. I want to calculate it for a specific value. So I want number 1. And my input value is 0.25. So I just type in 0.25, hit enter. It's nice because it actually shows you where it is on the graph. It tells you what that value is. It's 27.2. And it's centimeters. So we can write, don't forget the units, centimeters. Can this be trusted? Well, even though 20.25 is not actually one of my data values, I can see 0.23 and 0.26 are right there. So 0.25 falls somewhere between them. It shows up on my graph. I can trust it because it is part of my original data. So I'd say, yes, that does seem to be the right value. I want to show you another way to do this. And this way is also good for this one because 0.6 is not part of my graph. So I can't actually use the graphing method to do it. But I can go back to the main menu by doing second quit. That's the main screen. Then again, I want to use that Y function I created. So I'm going to hit that vars button, move over to Y vars, pick function, and then pick Y1. This is a function, just like f is a function. So we want to use functional notation, which is a function with parentheses. And in parentheses, we can type in what it is we want to find the function evaluated at. I want to evaluate it at 0.6. So I hit enter, and it tells me that this one is 38 as negative 38.2 centimeters. And it wants to know if it can be trusted. Well, there's two things that might help you understand whether it can be. First off, it's negative, which you might think, well, it can't be negative, can't have a height negative. But it depends on where you're measuring it from. If I throw something from my hand and I consider my hand 0, it could fall below my hand to the ground. So it can actually fall farther into a negative value because it's below my hand. But really the reason I can't trust it is because my data goes only up to 0.46. It doesn't go all the way up to 0.6. So we have no idea what's happening after it gets past 0.46. So we don't know really what's happening at 0.6 seconds. It actually could hit the ground and not be moving at all, and the height doesn't go anywhere. So we can't actually trust it because it's not part of our data.